So what all the other asset management solutions are doing, and what the status quo is basically reinforcing, is this idea of individualized asset risk analysis. And so that basically means I've got one pole, I look how old that one pole is, I've got some table that tells me based on how tall that pole is, what the material is, or what's on it, what happens if it falls. And that's just a generalization. And if you're making grid plans based on those kinds of generalizations, your grid plans will be wrong. The other thing to think about is if you're just looking at those asset risks in isolation and you're making a plan based on individual interventions, you're not grid planning. What you're doing is managing an inventory of assets.
Right.
But utilities don't own an inventory of assets. They own a grid of interconnected and interdependent assets that work together to deliver power. And so that means if, for example, I have a line that has a fault, I'm going to close some switches and I'm going to go through a bunch of different phases to restore power. And if I'm not modeling what happens when I have to decide to shed load or redistribute load throughout other parts of the circuit, I don't understand the likelihood of concurrent failures, and I'm not really modeling grid outcomes. In that sense, integrated grid planning, which is done with our solution ENGIN, can only be achieved with a bottom-up risk analysis that models the behavior of the grid to really inform where you need to spend money to make sure that you can keep providing safe, reliable, affordable power.
Okay, so you're modeling the grid from the bottom up, and so you must be ingesting a lot of information.
So we'll be integrating to a number of systems in the solution ecosystem that basically amount to whatever information I need to better understand first the likelihood of an asset failure, but also to produce a network connectivity model to tell me what happens when an asset fails, what customers see an outage, what kind of customers, how long is the outage, and what's going to happen from failure to restoration. That can't happen without a basically digital twin of how that grid is connected. And there are a number of systems, including OMS, SCADA, Historian, load flow modeling software, GIS systems, that'll all inform that model.
Okay, amazing. And so you said digital twin. Should I start thinking about you guys as a digital twin?
When you start thinking about digital twins, that can mean a bunch of different things.
Yeah.
That can mean a point cloud visualization, a 3D model. In this context, what we're talking about is a reproduction of the grid's connectivity to tell me when an asset fails, who sees an outage. So it's not a visualization digital twin, it's telling me the consequences and the impacts of an individual asset failures on grid performance and customer reliability.
Fantastic. So if you are interested in learning more, a couple of things you can do. You can visit Engineered Intelligence's website.
EngineeredIntelligence.com.
You can come see us in booth
4000.
Or you could also check out the session and the sessions that Engineered Intelligence did at the show through the Innovation Works DTech Decoded series, as well as check out their solution in our Innovation Works hangar, where you can actually book a meeting here with Damien in case you don't get a chance to see him at the show. Okay, hope you all enjoy that. Happy innovating.